so you're trying to draw a free body diagram for 3 different things, right? We have the cabin, the person, and the niece. Okay, so we have here cabin, person, niece, So let's start with the cabin first. Okay, so here's the cabin. Okay, so what forces do you think are acting on the cabin?
Gravity, the person, and the rope.
Good, good, good. Okay, so we have gravity downward, and the cabin is the heaviest thing that we're dealing with, right? So probably it's going to be the biggest of the gravitational forces that we're going to draw. So I'm going to make it nice and big. There it is. So this is the force of gravity on the cabin. That looks good. And then what direction is the person pushing on the cabin?
Up. Well, the cabin is
So if this is
down.
It's pushing down. Exactly, exactly. Okay, cool. So there it is. So, and I'm just going to make it like this. Oh, wait, sorry. There was a little wonky here. Change that. Okay, and so the force of the person on the cabin is down. And then, yeah, and then the rope has to support all of that.
Has to be bigger.
Wait. Yes. Okay, so now we have to figure out, right, is it going to be bigger or smaller than the sum of these 2 forces that we've already drawn? So the thing that we're going to look at here, and in fact, the acceleration is going to be down for the cabin. And actually the velocity doesn't matter at all. This really doesn't enter into things in any way, because with forces, all we really care about is the direction of the acceleration. So, okay, so the acceleration is pointing down, which means that our net force must point down also, exactly. So I don't know how big to draw the force of the rope pushing up. You know, so but it's definitely going to push up. It's not going to be, it's got to be smaller than the sum of these 2 together.
Yeah.
Right, so, okay, so there it is, the force of the rope on the cabin. It's always good to do these in pencil or whiteboard markers or something, so you can erase things. Okay, cool, so this looks good. All right, there's our picture for the cabin. Let's do this for the person, too. So the person, so we have, okay, I always start by asking myself, what's in contact with the person?
The niece.
The floor, that's it.
Yeah.
And then we'll also have gravity. Perfect.
Yeah.
So 3 forces total. So what direction is the niece pushing on the person?
Down.
Down, I would agree. Now the niece isn't heavy in comparison to these other things, so
That's the smallest one.
yeah, perfect. I think that's a good idea. You know, I'm going to make it really small. So the force of the niece on the person is down. And then the force of gravity on the person is going to be, yeah, so let's see, this one's about half the size of this one, so, you know, roughly, I'm just kind of approximating here, but roughly half, somewhere in here. This is the force of the gravity on the person. That looks cool. And then, okay, and so what's the direction of the acceleration for this person?
Isn't it 0?
Ah, good question. Okay,
Or do you assume that they're moving with the cabin?
you assume they're moving with the cabin. Exactly. So that's a great question. So yeah, so think about the niece and the person in the cabin. They're all moving together as a group.
So acceleration would be down.
They're all going to have the same acceleration. Yeah, they're all going to have an acceleration downward. Cool. Okay, so that means then that our net force on the person must be down.
So negative.
Yep, exactly.
And then what's it called? The floor has to be smaller than those 2.
And I'm going to, instead of calling it floor, I'm going to call it cabin just to keep with
Yeah, I call it
this.
cabin. Yeah.
Okay, perfect. So yeah, so whatever force I draw up here has to be smaller than the sum of these 2 forces. So my net force has to point down in the same direction as the acceleration. Okay, good. So here we go. So maybe something like that. I don't know. So this is the force of the cabin on the person. That looks good. Okay. And then the niece. what is making physical contact with the niece?
The person and
That's it. Yeah, I
then
agree.
put gravity.
Yeah, so person and gravity. Okay, so gravity's clearly going to pull down on the niece, and so, you know, I don't know, not that much, kind of small. So force of gravity on niece. And then what direction does the person push on the niece? Up, exactly. They're keeping the niece up. So yeah, so let's see here. In fact, maybe I'm going to make this just maybe slightly larger there. Because whatever force I draw up has to be smaller. Again, because the net force has to match the acceleration here. So net force has to be down, which means our down forces all added up have to be bigger than our up forces. All right, so force of the person on the niece. And now I'd like to go back through, now that we've drawn all three body diagrams, check to be sure you've got acceleration in each one. We do. And then check to be sure that all your second subscripts match. So, yeah, person, niece. Okay, so we are good to go there. All the second subscripts match. All right, so this actually looks pretty good to me. Now, what about
The interaction pairs.
interaction pairs?
I labeled them like X1 and X2 because I didn't know.
Okay.
how to label them.
Yeah.
But I did the person on the cabin
The person on the cabin.
and the cabin on the person.
And the cabin on the person. So the person on the cabin and the cabin on the person. So now, so here's the first X, and we double check
Because they're flipped.
because they're flipped. Exactly.
And then
So you flip their subscripts and you flip the direction of the arrow. That looks great. So that's an interaction.
the niece on the person and the person on the niece.
Niece on person and person on niece. And so the way I'm going to do this is I draw like two X's here, like that, to kind of show. It's a tiny little arrow, so sorry. It's kind of awkward. But yeah, exactly. You flip the subscripts, and the arrows are the same size. They're just flipped from each other. So yes, good. All right, this is looking really good. All right, so now we're at a point where we can do Newton's second law for each of these. Okay, now for Newton's second law, what I'm going to do is I'm actually, like normally I would go down on the page, but I'm going to actually, let's see, I'm going to put it up here. So, I personally like to start by writing out the gravitational forces for everything that I know. Because gravitational forces are just m times g. So we actually can figure out, you know, these three gravitational forces pretty easily. So what's this one going to be? FGC.
Oh, it's just mass times acceleration.
Exactly. It's just mass times, it's specifically g though.
Yeah.
So it's just going to be, this one's going to be 100 times 9.8. So yeah, all these gravitational forces, the equation I'm using here is just Fg, you know, FGC, for example, is going to be m of the cabin times g. And so it's going to be 100 times 9.8. So right here, 100 times 9.8 is 98 newtons. And you can kind of do that for each one.
Said 100 you said, right?
Yeah. Did I do my math right?
100 times 9.8.
Mm-hmm.
I got 980. I don't know why.
Oh yeah, 980. Yeah, 90. You're right. You're right. I just
Sorry.
no, that's right. And this one will be 190. Cool. So those three, I think, are. We can just kind of get those out of the way. Yeah, sorry about that. So now we can actually use F net equals MA for each of these individuals. And the key here is not forgetting the net on that equation. So for the niece, I'm just going to move this up a little bit. So F net equals mass times acceleration. And this is because you're dealing, I'm sorry, you're sorry.
Sorry.
No, you're okay. I'm sorry. I didn't mean to rush you.
I forgot to write down like the equation before. I just wrote out like the multiplications.
You're good. You're good. Cool. All right. So now we're here. I think it makes sense to start by talking about the niece. She has the fewest forces acting on her. She's only got 2 forces. Everybody else has 3. And so here we basically only have 1 unknown. And so I think that's going to work out well for us. So right now we're trying to find, like, what is this? What is the force, the person on the niece? So we'll start with F net equals MA for the niece. And in fact, this will be our starting point for each of these. So right now, so this is going to be, since we're talking about the niece, this will be the mass of the niece. And this is just the forces acting on the niece. So whenever you're doing F net, it's always going to be, you know, if you're dealing vertically, it'll be all your up forces minus all your down forces. So FPN points up. I don't know what that is, so I'm just going to leave that. FPN minus our down forces. So in this case, FGN, that equals M times A. And FGN, we just said that's 196. So we can actually plug our numbers in now. The mass of the niece was this 120?
Yeah.
Okay. And the acceleration was, it's downward, right? Or is it upward? Yeah, no, it's downward. And this is 1 meter per second. Excellent. And then you just solve.
So it's just 20 plus 196, which is 216. No, it's not. It's negative 20.
Yeah.
Minus 20.
No, you're good. I was double checking myself. I was, yeah.
Yeah, so 176.
176. Yeah, that looks good to me. Nice. So now you have this. You know that this is 176.
And since it's just flipped, you just flip the sign.
Yes. So over here, since this is an interaction part, it's kind of like filling in a puzzle. It like all starts to kind of crumble into place. So since this is
And the niece
176,
on the person.
yes, the niece on the person's got to be 176 also.
And can we just like write the
Yeah, you can just write that right in there. Yeah. And so now you can do the same thing, but this time for the person. So you're going to literally start with F net equals MA again. And M of the person times the acceleration. So again, F net's always all your up forces minus all your down forces. So FCP, I think, is the only one acting up. And then the other 2 are acting down. And that equals mass of the person times the acceleration. Nice. And now you've got everything but this